Good morning, everyone, or afternoon. Sorry that I can't be there. Take the first 4 minutes. Start on the do now. If you're subbing for me and you stepped in, please pause the video until you've finished and check back in with the answers. Thank you. Now, I'm about to go over what I would do for the do now. And the first question talks about something called slope, right? And we know what slope is. We know from a line, we can call this rise over run, but this is for any linear function. We can talk about the rate of change of that function if given 2 points on that line. We can call that change in y over change in x. And something to remember is that each value has an x and a y. And so when we're talking about the change in y, we're talking about how much it increased or how much it decreased. So let's just think about those y values from 6 to -8. Well, one way to actually find out how much it changed is to go backwards and do 8 minus 6. And similarly, for your x values, you could go backwards to see how much that changed from 2 back to -1. And you can kind of do this in your head. You can really count from 6 to 8. You know that that's going to be 2. And then from -1 to 2, you know that's going to be a change in 3. All right, we know that those two negative signs are going to make a plus. So your slope, your rate of change using that formula is 2/3. And so we're really going to be focusing on this formula later today, knowing how to find the rate of change. And how I did that was really finding the difference here. So if I were to highlight one thing, it would be the subtraction of those values. Notice how there's a minus sign on the top and the bottom, because I want to see how much they changed by, that rate of change, that slope. On number 2, we want to factor then solve this. Well, what we've got here is something equal to some polynomial 8x. And we know that we want this to be equal to 0 in order to factor it and then to solve it. So all we need to do is move that 8x over to the other side by subtracting 8x. And so we have 12x to the third minus 10x squared minus 8x equals 0. And we know from here that we could factor out a GCF of x. And what else? Let's see, I could factor out a 2 out of each one of those. So I get 6x squared minus 5x minus 4 equals 0. And I'm going to ignore that 2x out front for now. I'm just going to highlight it just so that I remember at the end that I want to use that in my answer. And now remember, when we're factoring and solving, our a term is no longer 1. And so that means we got to use our master product, or we got to do a times c, which in this case is going to be -24. Factors of -24, that will give me -8, 8 and 3. As long as the 8's negative and the 3 is positive. So we'll break this down into 6x squared minus 8x plus 3x minus 4 equals 0. And I'm just going to kind of remember that that 2x squared is out front for now, or sorry, that 2x, as I continue to work on my factoring by grouping. Now our GCF of these first two terms is going to be a 2x, and of the second term, I can only factor out a 1. And so I have 2x times some quantity plus 1 times some quantity. And then the inside of those quantities, let's see, I would get a 3x minus 4. And of course, if I divide by 1, that's going to stay 3x minus 4. And so, I forgot to set a parentheses out there. That's still equal to 0. So therefore, I have a 2x, I have a 3x minus 4, and I have a 2x plus 1. And if you want to think about where all of those came from, the most confusing thing that a lot of people forget is to put that 2x plus 1 inside one group and then 3x minus 4 inside the other group. The 2x just came down the entire time. And I think I actually forgot a 2x out here. I think there are two different 2x's. Yeah, this one. And also this one from the GCF there. And so I've got this entire thing equal to 0. I need to solve it. So let's set each one of these equal to 0. We're going to have 3 roots here. We're going to have x equals 0. We're going to have x equals 4/3. And we're going to have x equals -1/2. Now, if you wanted to know how I do that, I really just set each one of those equal to 0 and I solve them. Okay, that is your do now today. A little bit of factoring review. But again, the big focus today is we're going to go back in time and talk about slope. Now, remember that slope was for all linear functions. Keep that in mind as we go through for today. But before we do that, let's go to our Mad Minute. And for your Mad Minute, we have to identify all roots and root behavior of each one of these. So take a moment, think to yourself, root behavior. What does that mean? root behavior tells us that we're talking about multiplicity, right? And so with something like this, I want to look for that multiplicity, and I want to know, does it bounce or is it going to cross at that x-axis? So not only do I need to find my roots, I need to know what they're going to do when they reach the x-axis. So in something like these, to identify our roots, I should think to myself, well, do I have everything that I need? And it looks like here, I don't have everything factored. So really in this do now, or this mad minutes, you're gonna have to do a bunch of factoring, finding those roots, and then identifying those multiplicities. You should all take 5 minutes to factor, find the roots and those multiplicities, and then check back in for your answers. So if you're moderating, please pause the video, for I'm about to reveal the answers. Okay, and here are the answers. You can see all the work that I have here. Number 1, I just broke down my factors. -3 and -3 gives me a +9 and a -6. And then I left the -3 here. And then for this x squared minus 9, that's a difference of perfect squares. Remember those? +3 and -3? That's going to break down. And so here I can actually group some things together. And I didn't do it, which I'll show you in number 3, how I can regroup those. You'll see that I have 4 different x minus 3s. And so remember that the root of that factor is going to be +3. Remember how that flips around, and that there was only one that was x plus 3. And so we had one root of that x equals -3. And remember that any time that we're talking about multiplicities or root behavior, bounce happens anytime that the multiplicity is even, and anytime that multiplicity is odd, that tells us that it's going to cross. Okay, so this is really what we want to get into, and knowing exactly what those roots are going to do at each one of those. And so if you look down to number 3, you can check your answers for 2 and 5, or 2 and 4 as we're doing this. If we look down to number 3 right here, this is a lot. We had a difference of perfect squares. That's where the x plus 4 and the x minus 4 came from. X plus 4 just came down. So I just kind of copied that one down. It was already factored. X squared minus 4 is another difference of perfect squares. So +2 and -2. And then lastly, we had just this, right? Trinomial, where we have 4 and 2 are the factors of 8 that will add up to 6. And so when we have those, now we can actually put those together. I'm just going to do some underlining here. And so we have, let's see, how many different x plus 4s? 1, 2, 3. And so you can see that I actually grouped those all together to put an exponent of 3. There's only one x minus 4. There were 2 x plus 2s and 1 x minus 2. So you can see those multiplicities down here. And you can actually also see if C, C, C for cross, and B for bounce. And so remembering that that's what we're looking for in multiplicities. We need the factors, we need the roots, and therefore we can decide what that root is doing at each one of those. Okay, this is how we were graphing really kind of crazy functions. Now what we're going to talk back about today are just 2 different types of functions that we already have done way back in Algebra 1, which is quadratic and linear functions. And so with each of these today, we are going to remember from this do now, the change in y over change in x. And so what you all need to do right now is you're going to put this in your packet, and this is going to be like your notes problem. So highlight right here. This is 2.08. We're going to call this average rate of change. Okay, so for each of the following, we're going to find the rate of change. And I'm going to abbreviate that to be ROC from x equals -2 to x equals 2. Take a moment, make sure that you have that written down. If somehow I'm going way too fast and you're in the room, you can pause this video, because I'm about to scroll down where you're going to lose all that text. So we're going to be going from -2 to 2. Okay, now what does that even mean? Now, what we are really talking about, if we're talking about rate of change is change in y over change in x. This is the slope. This is for linear functions only. Remember that for linear functions, there's going to be a constant rate of change. That rate of change never changes. So it really doesn't matter which 2 points you choose to find the rate of change of in a linear function. It's always going to be the same. And so when we're talking about rate of change of something like this, this is a quadratic. And we can see that this is not a straight line. So that rate of change is going to be changing constantly. And so what we're going to do is we're just going to find the rate of change between 2 points. We're finding the rate of change between -2 and 2. And so what we could do is we could just come to our graph and we could just identify those points. X equals -2 and X equals 2. So we have the point -2, 3. And we have the point 2, -3. And what we want to do is we want to find the rate of change going through this. So what that would look like is if we were to draw a straight line and connect those, pardon that that's not so straight, we would actually want to know what is the rise over run, what is the slope of that straight line connecting those. Obviously, the graph is not straight, but we could connect those and find approximately how much this is going down in between those 2 values. And so remember, our formula is change in y over change in x. So when we do this change in y over change in x, all I'm going to do first is I'm going to put my 2 y values in the same order. So I'm going to put 3 minus, and then I'm going to make sure to put the entire second y value, which is -3. Notice how I have a 3 and a minus and a -3. We're finding how much it went down, so we have to take the difference. Same thing for this next part. We're going to start with a -2 minus, and then we're going to use the other value 2. And when we do this here, let's see what we get. We're going to get a +6 up top and a -4 on bottom, which reduces to -3 over 2. Now, if we were to go kind of check our answer, of course, our slope should be negative. It's going down and to the right. And we can actually go down 3 over 2, down 3 over 2, and actually walk that using rise over run to check our answer graphically. And it works. There's our answer. So that's how I would do it from a graph. I'd choose the points, and I would subtract the y's and subtract the x's. So same thing for function b. Remember that we're looking for between -2 and 2. And so we want to find that change in y over change in x. And so let's first take a look at our y values. This is in this column. I'm going to go from 4 to 4. So make sure that I subtract in between, and I'm going from -2 to 2. And notice how, again, I'm subtracting in each one of those problems. That gives me 0 over -4. And you should remember to yourself, what does it mean when I have a fraction when 0 is on top? 0 divided by anything is 0. And so look at the process here. Once again, I just took my y values and subtracted them, and I took our x values and subtracted them. Function c. This one's a little bit different. You are not given those points. And in fact, you really only know the x values. So first, what I'm going to do is I'm going to find my y values at 2 and my y values at -2. So let's plug in. I'm going to get negative. And notice how that negative is out in front of the x. That's going to come down afterwards. That doesn't go in with the 2. -6 times 2 minus 11. So now order of operations tells me to do the exponent. Then I'll bring down the negative. Remember, that really matters where that negative is and where the parentheses are. And then we'll subtract from left to right. That's -16 minus 11. That's -27, right? Yeah. And so now I know a point. One point is 2, -27. But I don't know the other point. So let's plug in -2, right? Because the prompt up here said we're finding the average rate of change in between those 2 values. So if I plug in -2, remember that negative stays out front, and I have a -2 inside parentheses. So this is going to give me 4, +4, but then I got to bring down that negative. -6 times -2 is +12 minus 11. And if we subtract those, we're going to get, what is that? 8 minus 11, -3. And so our other point is -2, -3. Now, how do I use these again? Well, if these are our points, let's just once again mark which one is x and which one is y. And let's go find the change in y over change in x. Change in y, let's start with the negative 27, and then let's make sure to put a minus sign, and then go to negative 3. Notice how I'm always going to have a minus sign, and then if I look on the left and right side of that, the negative 27 and negative 3 came from those points. So there's always going to be a minus sign in between. All right, let's look at the x values. The x values come first. I'm going to start with 2. I'm going to put a minus sign, and then I'm going to write down the negative 2. So once again, always going to have a minus sign, and then those other two values on either side of it come from our points. We're subtracting to see how much it increased or decreased. So in here, I got 27. Those are going to form a plus because there's two negatives. That's going to give me negative 24. And then the two negatives there also become a plus. So negative 24 divided by 4 is negative 6. And there's our average rate of change. So I don't really know what's going on in this function. It's some kind of quadratic. And between 2 and, negative 2, wherever those are, they're connected by a straight line. And that straight line that connects those 2 points has a slope of 6. That obviously is not the slope of the quadratic itself because it's curved, but it's really just kind of estimating from those two values how much it is changing. Make sure that you have those in your notes. If I've gone too fast, you can pause the video until you have this, but just know that we're subtracting y is on top and x is on bottom. And if you can do that, you'll do just great. Your objective today is now to go ahead and do a couple of these on your own. You've got all of you do round 1. Great. Go ahead and do you do round 1. It's going to ask you for the average rate of change on some interval. And so when it says something like that, I will just point out when it says an interval -1, -2, they're giving you the x values. And they're basically saying from x equals 1 to x equals 2. So they're actually giving you the x values here. And so once again, in number 2, they change it. They're saying from -4 to 5. Nothing changes. What I would want to see from everybody on these is change in y over change in x. Show me how you're going to do it. Moving on past problem set A. Into the we do, you're going to skip the we do. You're going to go right to the you do round 2. You do round 2. Very similar. Look in your notes. You're going to be given some equations here. Think about how I solved those using those equations in the notes. Finish this and go right to the exit ticket. Good luck. Godspeed. See you soon.